Color and aesthetics, we have some links here, and the points of significance, if I can get there. There's another site I'll send you to, and there's a nice article on the use of color in scientific graphing, a little bit on the misuse, and then a few other links on how to use color. I don't have much in color sense, so I will refer you to others who do. All right, so next thing we want to do is we're going to download the malaria for graphing, and then zip it, and then we'll go back to the statistics terminology. All right, and go ahead and download the statistics terminology. Those are the two things that we'll be looking at today. I guess I should go. Theoretically speaking. All right, if you're looking at the statistics terminology, I sometimes get the complaint that there are thousands of terms in here. Not really, it's just slightly over 100. So as it's not a heavy terms class, you're thinking 100, that's a lot. But I mean, it's not like Intro Psych, which has over 500 new terms that you've never heard of. Anybody take an Intro Psych? Yeah, there's a lot of new words in Intro Psych, and some of them even make sense. So we don't have a ton of words that we have to know here, but there are a few. If you know this set of terms, you will better understand the words coming out of my mouth. I will try to explain them. If you don't understand, please just stop me. All right? Let me see, did I get it from the bottom here? All right, the other thing is, whoa, stop. Is that I also have a chart of different types of analysis for different types of variables in here. This is a standard canned one. I have another Excel sheet which we will use a little later and add to. One of the problems that's been identified in intro stat classes or in stat classes or in stat education altogether is you don't really get the necessary types of statistics until you're in your third or fourth graduate level statistics course. Here we will do a ton of different types of methods, and the question is, how am I supposed to remember which ones to do? Well, sort of look at the chart, right? And we'll talk about what variables are. What is your output variable? What's your input variable? And what kind of analysis do you do? So today we're going to work a little more on variable types of graphs that go with variables, and not today, but in weeks to come we'll move from graphs to analysis. We've already started. Today, in what we've done so far, I've given you a graph and the type of analysis that went to it. Today, I will not do that nearly as much, but we will do some more, essentially some more graphing. So where do I go? And again, the second table in here tells you the type of mathematical operations that you can do on a variable. You can't average yellow and green. Well, you can in some sense, right? If you mix them together, what do you get?
Yellow, green.
Greenish yellow. Red and yellow, you get orange, right? But when if two people are standing, if the average color in here, right, is blue and gray, nobody's wearing halfway between blue and gray, right? Some of you are wearing red. We've got red and black there. Halfway between red and black is not the average color. So we have to be careful about the types of variables we're using. And I'm going to go through them again. Nominal is name only. You can't add or subtract those in general, all right? Ordinal, order matters. Small, medium, large. Although large is getting smaller, and a medium now looks like a small. In terms of drink sizes around here, a cup of soup is now a baby cup. It's like the doggy dish size at Meadows. All right, but those are things that are ordered. We can't add or subtract those either, but there's different kinds of statistics that we can do on those. Then there's interval. things where the distance between two is exactly the same, so 1 person, 2 person, 3 person, those are interval, right? But there's really no such thing as half a person that's still alive, all right? So we don't count that. So they're interval variables that go. We typically add and subtract and divide interval variables, although it creates some issues for us. Ratio are things where division makes sense and 0 makes sense. 0 in a ratio variable, 0 means none of the item, all right? In most interval variables, 0 doesn't necessarily mean none of the items. Ranks. Ranks are a type of interval variable. It has some neat properties that we'll get into. Counts. Counts are like an interval variable, but counts statistically create issues for us. And people doing genomics live in the world of counts analysis, right? You don't do the standard. For years, people tried to do genomics using linear and smooth type analysis and got lots of wrong answers, and only a few people died. And so it was only a few. When science gets it wrong, not too many people die. When engineers get it wrong, lots of people die. And then there's some special binary, yes or no, on or off, 0 or 1. Those are also give us some interesting. Cyclic variables are really problematic because, like time, it comes back to the same value over and over and over again. And so the larger you get, the closer you get to being small again. And that's problematic for doing statistics. And as we get later into the class, we will work on these. Can you add cyclic variables? Sometimes, carefully, with ifs, and they're disjointed, and they're problems. So we will go through these types of variables, and this is the one that you're going to be working on a little bit today. We're going to use a data set that I downloaded from Data Dryad, and we'll talk a little bit about data sources, maybe later today, maybe Thursday. But I downloaded a data set from a paper. Many people are required to publish their data with their papers, and many journal editors require it. Trust me, people put out crap data with errors in it intentionally. You'll see some of that as you go looking for data. But we're going to work on a data set today and increase our graphing. The first thing we're going to do is make sure that our R is set up correctly. So please open R and do library R commander. All right. Does everybody have, anybody not have it up? Good. All right, so the next thing we're going to do, you'll see KMGG plot 2 here for me, but we're going to go to Tools, Load R Commander Plugins, and you should see R Commander Plugin.kmgg plot. Click on it, and then it will tell you, and OK, and it will tell you need to restart it. Okay, and then once you restart it, you should get you should see it. Yes?
It's not visible.
Go to the Google script. Yeah, go to Anybody else having that issue? Okay, so go to Google, go to the scripts to install. In day 1. And just grab that first line. paste it into your main R window and hit a return. Are we good here? All right. All right, we will do a few more add-ins later on, but for now, this will be enough. Please go to your downloads or wherever you put the malaria for graphing. Right-click and extract all. And on Mac, people just double-click and extract it. And that should give us a malaria for graphing. In there are 4 data sets. We are going to open the R1 directly. We're going to go into R and load that. But I have the original data set and I've given you the malaria metadata. We will probably need this. At some point, this tells us what the variables in the, you will definitely need it for the assignment. Okay? And so it will tell you what the various variables are and some issues about this. We'll do some graphing and then we'll bounce back to here and figure out what the various variables are. Although that's an impatient strategy, it's the one we're going to use. All right? Is everyone with me? Everybody's extracted those? So let's go back to our R commander. We'll go to data, and we're going to load a data set. We're going to have to go to the malaria for graphing, and we're going to grab the malaria no missing 2. Yes?
Or commander will come back up.
Type commander with a capital C. If you lose your R commander window, you get back with commander capital C, all lowercase. Fine, and it should pop up and you'll end up with the blue data set. Yes?
Loading the Excel or the R?
The R. We're doing load and the R. We have to import Excel and load R. Anybody having issues? The commander worked? All right. I'm going to click View Data Set to make sure. So we have a patient number, treatment group, how old they are-ish, village, hemoglobin levels, did they use bed nets or not, how many days into the study, minus 28 is sort of when they contacted them, 0 is when they started doing measurements. And then we have sort of a variety of malarial incidence measurements, and we're going to mostly work with the log prevalence. All right? Well, we have treatment group is what kind of variable? Nominal, categorical, categorical or nominal, yeah, it's a name only. Age is what kind of variable? Does 0 mean no age? Yeah, so it's a ratio. Okay? Hemoglobin, get another ratio, enroll. Days. It's measured as interval here, right? They didn't measure, like, we got you at 10 in the morning, we got you at 4, so it's measured, yes.
Sorry, which are we loading and which are we importing?
We're not importing anything, we're only loading the one data set.
Oh, okay, that's,
So once, yes, so we're just loading, sorry, I said that. If it's an Excel file, you have to import it. If it's an R data file, you load it. We're only doing the load. Are you good to go? All right, so we're gonna go ahead and close this down. Sometime, there's a way you can change R into, so you can have multiple files open at the same time, but if you do that, then everything's going wrong. So we're gonna close things so you don't crash. You get too many things open, R will crash on you. All right, do we see the KMGG plot up here? So we're gonna go to KMGG plot, and the first thing we're gonna do is a pie chart. You know, you probably have been told pie charts are a lousy way to represent things, but I like them. All right, and so do people at places like WHO and the consulting firm that I'm working for. All right, so we would like to know how many BedNet enrollees by village, by treatment group. Yes?
I don't have the KMGG part 2 on the hidden part.
Okay.
Tools. Loads, KMGG plot at the bottom.
All right. So that's sort of one way of looking at this. So we have a nice comparison by village of, it looks like some of these villages didn't have any Primaquine plus other anti-malarials. They had a sort of shotgun anti-malarial approach, which is let's give you a whole bunch of different anti-malarials to make sure we didn't miss anything with resistance. So it's sort of like gin and tonic followed by Vlad. Is that going to make you feel sick? Yes, it is. And so is shotgunning malaria drugs. All right. Been there, done that. Not fun. You feel bad. Which is why kids don't want to take the malaria drug until you feel like you're really hungover all the time. It's horrible. All right. But so you can see there's nothing resembling balanced treatments, but this is just a graphics exercise. So let's go ahead and copy that as a meta file. Let's open up a PowerPoint document. And Mac people, you can just paste it. Okay? So we just want to keep a little bit of a record of what we're doing here. Okay, yes? Go over to your base R, and it's probably hiding in the lower right corner. Close your data set. All right. Okay. Did you do your pie chart for KMGG plot? What? Oh, sorry. Now select treatment and village, I believe. All right, now you have to go back to this here. Go over here. And then it's minimized. Close that. Yeah, then we'll go to KMGG plot and go to pie chart. And we get that
Excel 2010. So nothing was
Bednet? Bednet? All right, then we're going to go back to your base All right, let's bounce back to the R command. We're going to be largely in the KMGG plot for the rest of this session. We're going to go to the KMGG plot. Let's go back and do our pie chart again. And let's try village by treatment group by bedroll. And OK. Village by treatment group by bedroll. So how we order the faceting can drive very much the story that we're telling. Okay? And the question that we're trying to answer here is, if you have bed nets, do you need to do mass drug administration with clinical? Okay? With these nasty things that make kids feel bad that they don't want to take. All right? Anybody here take antimalarials? Did you take them? How'd they make you feel?
Fine, unless I didn't eat before I played.
Oh, yeah, okay. Yeah. They're also usually contraindicated with alcohol. So, usually. Some people it doesn't bother. All right, so, and then, so which way did we do that? Village? If we come back here and we look, we can sort of see the level because it's tossing our, right? It's village, treatment group, and bed nets was the way we did that. It shows us this in the, okay. And we could go back and do it the third way, but I'll leave that for you to do later. Let's go ahead again and we'll look at that as a bar chart. And let's do village. And now we end up with treatment group and bed net, and this may, we're going to leave it at percentages. X variable is village, treatment group, and bed nets. Bar charts are another way to represent data. Right? This is part of the child pipeline. Or pain line, as people like to call it. It's, you know what? Yeah, once you know how to do it, it's not that bad. It's only the first couple times through that people cry. All right, so again, our village is a little rough to read there, so we're going to stretch it out, and there are some ways we can flip village later on, so it's easier to read. But we just
That KMGG.
yeah.
Okay. Final weighted.
Pardon?
Final weighted print.
Oh, were you over the non-KMGG version?
I was.
Yeah. Okay, yeah, it's, if you got the order different, it's gonna look different. All right. So this gives us the similar to the pie chart, but again, some people don't like pie charts even though it's the same information. And we can flip this to get a different look. So you're understanding we have graphing types that allow us to do even up to 4 different categorical variables. You might have noticed that we're doing categorical by categorical by categorical. And so we're essentially building a graphical table here, right? These go into a table, and then we create a plot out of those tables. So this is just a graphical table, right? Putting tables up on a screen. Is everybody here? If not, stop me so I can.
What were your variables for the bar chart?
I believe I did village, treatment, and bednet.
So X variable village.
Yeah, village, treatment, and bednet. I got the different colors just by grabbing some different colors. All right, Tufty is going to be more minimalist, but you notice that there's not the extra boxes and stuff up there. The Tufty approach, if somebody says, well, you know what Tufty says, and they want you to be Tufty-like, grab the Tufty format, which allows you to be more minimalist. Okay? We good on that? We understand that we can do categorical by categorical by categorical, and if we had a 4th categorical variable, we could even make this more complicated. All right? So, let's go back now. We're going to move from categorical by categorical to categorical by continuous. Okay, and we've already done categorical by continuous. We did that last week, but we're going to go categorical by continuous. So let's go to KMGG plot. We're going to do a box plot. Our X variable here is treatment group. That's our causal variable, our treatment group. And then we're going to do our log prevalence. And let's facet by bednet. And let's do a 95% confidence interval with a t-distribution. We're not putting anything in stratum. We're just going to facet. And we'll say okay. And here's hopefully, and this is Tufty, which is minimalist. So it's going to look fairly different. All right, so do we see, these are 95% confidence intervals, right? So is there a difference between the Primicon treatment and the placebo in no bed nets? Is there less malaria? Is that probably significant at the 0.05 level? All right. Is there a difference between bed nets, between placebo and when there are bed nets? No. So if we could get everybody to use bed nets, we wouldn't have to give them drugs to make them sick. Or at least that's the outcome of this story. All right, so now we have categorical by continuous. And let's go ahead and we'll look at that in a box plot format. Let's save that one. And I know yours is going to look different than mine because you probably have a different style chosen. All right, let's go ahead and go back to our box plot here. Except this time we'll actually run a box plot with the same treatment, log, and bed net enrollment. But we'll run it as a box plot. Okay. Do you want me to run through that again? X is treatment group, Y is the log, and facet is bed net. Okay? Are there a lot of ties? What's the minimum? What's the first quartile? All of these. What's the first quartile? 0. What's the median? Zero. Right? All of these have their dark line down there at 0. What's the 75th or third quartile? 75th percentile or third quartile? Zero for most of them. Yeah, and then 4 for the placebo in no bed nets. All right, so mostly this is a case where kids don't get malaria in the study. So box plots aren't particularly useful, right? And analysis of things around the median aren't particularly useful because we're not able to have that. The interquartile range is 0, right? So there's no way for us to tell if there's any difference between these. So when we see box plots that look like this, a non-parametric world is not our friend. So Kruskal-Wallis test and that. What's the minimum requirement for a Kruskal-Wallis test? Symmetry. I don't expect you to remember this week to week, but within a week from now you will. It means it sort of is a smooth distribution. So in this one we're stuck using sort of t-test type analyses. And let's bounce back over to our commander. I ran that just to show you that we can run it, but it doesn't give us anything useful. If it looks in such a way that you would have a hard time interpreting it, don't use that. All right, so let's go ahead and rerun our box plot. And again, we're going to look at treatment group. We'll look at our log and our bed net, and I'm going to get off of we'll go back to default here. All right.